Hi, everyone, and welcome to Building SaaS on AWS, the flagship show for building SaaS, but this time on Twitch. And this is the show where I, Gunnar Grosch, developer advocate at AWS, bring on SaaS experts to talk about how to build SaaS on AWS. So if you're planning to build or if you're already building a SaaS product, this is the show for you. So like I said, I bring on SaaS experts to dive deep into SaaS-specific topics so you can learn more about building SaaS on AWS. And this week, I'm happy to be joined by Mehran Najafi and Ujjwal Bukka, two returning friends of the show. Welcome to the show, both of you.
Thank you, Gunnar.
Thank you.
So we'll do the quick round of introductions like we normally do. Mehran, maybe start with you.
Sure. Hi, everyone. Good morning, good afternoon, good evening. Mehran Najafi, I'm a senior solution architect with AWS for over 2 years now. Before that, I was working for IBM for about 10 years. Inside AWS, I'm part of two technical field community, AI, ML, and SaaS, and that's why I'm here. I'm very happy to be here and talk about how to build SaaS solutions using AI, ML.
Thank you, Mehran. Welcome. Ujjwal, you next.
Hi, everyone. I'm Ujjwal Bukka. I'm a partner solution architect with AWS SaaS Factory team. And again, I'm happy to be back here with some more new stuff to share with you guys. Excited to share our research here. Thank you.
Yeah, is it third or fourth time for you now, Ujjwal?
Yeah,
Fourth?
it's fourth time. Yeah.
All right. Glad to have you back. All right. So, like I mentioned, every time we do this show, we have specific topics to talk about. And this week is, of course, no different. Now we're going to talk about AI ML, but in multi-tenancy for SaaS. So we are basically doing an AI ML multi-tenancy shootout. We're going to have Amazon SageMaker on one side, and we're going to have Kubernetes on the other side. So, Mehran and Ujjwal, you will be handling one of the two, of course. So maybe we should start out by talking a bit about some different multi-tenancy in AI ML use cases. Is that a good way to start, Mehran?
Yeah, I think that's a perfect way of starting this. Let me take this, Gunnar. So 10 years ago, or even 5 years ago, the persona and type of customers that I was working with them to build AI ML solution was mostly, big banks, big organizations that lots of effort to bring data from different sources, cleaning data, train a big model, and that model used internally. Usually, we were talking about a big, giant model for one or two usages. But now I have a customer that they are building model, thousands of models, tens of thousands of models, customizing it for each of their tenant, each of their customers, hosting it on different platform. And this is not even big organizations, just startups. So it's very different type of applications now that the companies that they are willing to share their internal model for the, they make money, right? So they expose it to the public, they expose it to the other customers, to the other tenants on different tiers, and very different type of use cases and challenges that they have. If I want to make it, a bit more formalized and put them into different categories, I'm in the field. I'm seeing two type of use cases. A pool use case, a shared model, where different tenant data, they contribute to build one model, and then that model will be shared on different tiers and different different endpoints for different tenants. For example, we all have heard and used ChatGPT, right? It's a giant model, 175 billion parameters. That training, it takes weeks, right? But the same model will be used for everyone. I'm very sure very soon, this type of large language model can be customized for different use cases and can be hosted differently. That takes us to the second category of use cases. For silo, company, SaaS provider can customize a model for each of their tenants. I'm like a part of AWS. We are working with a company called Zendesk. So they are building chatbots for help desk for their customers, and they host thousands of models, like tens of thousands of models on AWS. So not even one model per tenant, multiple models for their tenants. So you can see here we have one or more models for each of the tenant that can be hosted on different endpoints. So when we talk about multi-tenancy, you can think about these two. Sometimes we have same model hosted on different platform and different endpoints. Sometimes we have even multiple models for different customers.
And is that solely based on the use case, or is that also a matter of, like, when we talk about silo or pooled when it comes to perhaps the infrastructure, could that be a reason also to do this separation?
Exactly. Yeah. Sometimes you have lots of load on your model, your inference, that you want to just put them into the different tier. You want dedicated infrastructure, dedicated services. And sometimes for economical reasons, you want to have shared. And we will talk about that one a little bit, that how you can share infrastructure to support even dedicated models.
Right. Okay, so we already have some messages in the chat. So hi, everyone, and thanks for joining us today when we are putting Amazon SageMaker against Kubernetes in our AI ML multi-tenancy shootout. We already have some fighting words from Robin. I can see that is the answer always not to use Kubernetes. So yeah, that's one way to put it. We'll see if Ujjwal agrees with that later on. All right. So hi, everyone, and thanks for joining us. So then, well, maybe we should then move over to talk about these platform choices. That's the topic of today. Basically, SageMaker versus Kubernetes-based solutions.
Yeah, so if you talk about, you're building a SaaS solutions using AI/ML services, you have a couple options. The one option is, like, if you look at AWS, there are a lot of services which you can pick up and customize them for your use case. If you're thinking of building a custom ML model or machine learning model, then you would choose a SageMaker. SageMaker is a fully managed machine learning service. It provides you a way to build, train, and deploy your models, and also it provides you a way to inject a custom algorithms and custom frameworks to it. It also provides you some common algorithms which you can use. Not only these, there are a lot of other features in SageMaker, like model monitoring, etc. You can go deeper into it by looking at its documentation. That's the SageMaker side of the story. But if you're looking at the open source tools or options, then you can build ML workflows on Kubernetes. For that, you need to use a project or a framework called Kubeflow. Kubeflow, you would install the Kubeflow on top of your Kubernetes, and Kubeflow helps you to build ML workflows. So basically, you can build, train, and deploy your models on Kubernetes clusters using Kubeflow. And there is a Kubeflow on AWS open source distribution. If you use that distribution, then you can easily integrate with AWS services. So for this session, for the demo, which you will see in a bit here, I used the Kubeflow on AWS open source distribution and installed on an EKS cluster to show you the demo. Apart from these, there are also other open source frameworks like Bento ML or Seldom Core, all other frameworks. But as a part of this session, as Gunnar mentioned, we'll mainly concentrate on SageMaker versus the Kubeflow / the Kubernetes. So those are some of the options, Gunnar, you can pick and choose from.
All right. So then, well, let's start by SageMaker then, Menon. Maybe you can talk about SageMaker and more specifically how SageMaker then implements multi-tenancy in the flow that you just discussed.
Yeah. And, I assure you is that there are different platform and different solutions for some reasons. It's not that, we can always say we want to use with this platform and we don't use the other one. So when we talk about SageMaker, is managed AI ML platform, as Ujjwal mentioned, with AWS. You will get many managed services for your training, processing of your data, inference, and monitoring, and so many other AI ML. The reason we are here today is about SaaS, right? So I'm going to show you some of the SaaS and multi-tenancy aspects of SageMaker. And when we talk, both of us, what I want to highlight is that, you can do whatever you want with every platform, right? But the question is that how easily you can do it, how fast you can do it, what are the costs, right? How you can make sure that you fall forward and fall fast, so you can experiment faster. And that's where I think that SageMaker shines. So it really enables you. It has many built-in multi-tenancy and SaaS features that I'm going to highlight in my demo. But just think, I can do this here this way. I can do this on EKS, on Kubernetes the other way, on other platforms the other way. It's not about you cannot do it, it's how you can do it. So this is, I'm going to show you and talk about those multi-tenancy aspects inside SageMaker. This is my dashboard, right? I'm going to the SageMaker. If you haven't seen SageMaker, you can go to your AWS dashboard, find the SageMaker, and it provides you different services. I have a domain, so that's the starting point usually. I'm going to launch my notebook. So that is the managed Jupyter notebook, so that you can interactively work with your models. So it should coming up quickly. Yeah, so you can see it here. For the scenario I'm going to show you, so let's think about, as a SaaS provider, you own a model to predict and evaluate some like a property value, right? So you tell the model that how many bedrooms, where the property is located, some of the recent prices of those neighborhoods. You provide that to your SaaS model. Your tenants, they provide those information for your SaaS model. You train that SaaS for every customer. Let's say every city, just think about every city is one of your tenants. You train a model for them and you host the model for them. So you can see that, for the number of cities that you have customer there, you might have different models. What's important in SaaS, is that we really want to have one source code, right? And then we want to customize it based on different tenants. We really hate to have tens or hundreds of source code, different versions. It's very, very hard and costly to manage them. Where we start, we can define a SageMaker project. You can see here. And inside that project, first of all, it has integration with a Git repository, both a code commit from AWS, or it can work with external GitHub and other repositories. So the code is hosted here. I'm going to show you later. But remember, I said that I'm going to talk about those built-in multi-tenancy features of SageMaker that make our life easier to build SaaS solutions. One of them is pipeline. So pipeline is the ML ops portion of SageMaker. You can define a workflow of different steps in your ML flow. For example, you can get the data from S3, EFS, or other storages, bring the data, massage it, clean it, do some feature engineering. When you're happy with that data, you can train a model. Then you can evaluate a model, make sure that it meets your performance. And if it meets that performance, you can register that model. And this flow is customizable. You can put different type of steps here. But what's important here is that we can use the same flow for different tenants. How? By using parameters. We can pass parameters. For example, there is a field here, input data URL, that I can pass where the location of the data for this tenant. Just back to our example, every city, let's assume that every city has a S3 storage bucket. We can pass the URL of that S3 to this pipeline. And then pipeline can have different executions for each of those tenants. So you can have multiple execution at the same time that will be running separately for each of the tenants. Now let me show you a little bit of the code. So, like Python libraries, you can import them. Is it too small, or can read it?
Yeah, it's a bit small, I think. Maybe that's better. Yes.
Is better now?
Yes.
Yep.
Okay, so you can what I showed you as a graph, you can define different steps and put them into different flow. And you can pass some parameters, right? So those parameters could be the location of the training data, or the instance count. So for example, you define different tier of tenant. For a bronze tier, less expensive tier, you really don't want to use GPU, for example. You want your customer happy to wait longer and pay less. You pass, the type of, I want only CPU, just a cluster of one CPU, and it could take 10 hours. You pass that. For your premium tier, like for a gold tier, your customer cannot wait. They are willing to pay more. You pass, the type of CPU as like the type of processors as CPU, GPU, and like a cluster of 100 of instances. So you can customize your pipeline by passing those parameters. The other interesting thing is the role. So, identity access management in AWS is usually handled by IAM services, where you can define that, which service, you have access to which service, which resources under what conditions. You can pass a role to the pipeline execution and make sure that the pipeline execution for one tenant cannot access other tenant data. So really, we can enforce easily those access management here. And remember to my first comment, how easily you can do this. It is very well integrated with IAM. So we really can separate, and we will talk this later about isolation, but really can enforce that isolation using the IAM services inside the SageMaker and pipeline. Another interesting thing here is that, so we have different steps, right, inside our pipeline for processing of the data, for training the model, for evaluating of the model. All of them are kind of processors. What's important here is that when we define this, and when during that pipeline execution, SageMaker pipeline is going to create dedicate instance for your training, for your processing, the moment that workflow hit that step, right? So let's say that your customer is submitting training data every day. That time that data is submitted, a pipeline can be executed. When that pipeline workflow get to the processing data, SageMaker create instance for you based on that instance type and count. It does the training, it does the pre-processing. And when that pre-processing training done, it kills that instance. And then it will be charged per second for that duration of the time that that processor was working. This is really cool, right? Because it helped with that noisy neighbor problem. Like one tenant processor doesn't have access, or it doesn't do anything with the other tenant processor. Make it much easier. And as I mentioned, you even didn't think about this, right? You didn't think about, I want to build it this way. SageMaker does it for you. It build you, you don't have to have some resources idle there waiting for some customer to submit training data and you pay for it all the time, right? So you have that instance ready and just does nothing, doesn't bill you anything. When the data comes, SageMaker initiated and start. So it happens the same for pre-processing, training, evaluation. When when the evaluation is done, we can register the model. We are happy with the performance, and then there is a concept of model registered here. That's another cool thing, and with built-in multi-tenancy inside SageMaker. Let me quickly show you. Sorry, here, let me go back.
But what you just talked about, it also means that you're able to then bill your tenants based on their actual usage as well.
Yeah, exactly. So you can build it, and where is okay? It's my project, and this is my. You can have different model groups inside your model registry. I had a better example here. If you go to inside your models, there is a model registry. You can dedicate a model registry for every tenant. And if you don't know about what model registry is that, when your model is trained, the model artifact, which are basically the weight of your model, is stored somewhere like S3. You can register all the information, metadata about that model inside the model registry. For example, here you can see, for tenant 1, I have one model registry. I have a different one for tenant 2. So I have trained 2 model, version 1 and version 2 for this one, for tenant 1. And, I might have 10 different models for tenant 2. So, easily separated, isolated, and these models, they don't do anything with each other. So they are fully separated and isolated from each other. You have your model trained, you have your model registered. After that, you usually want to deploy your model. SageMaker, it provides you different options. Simply, you might want to deploy that model into an endpoint, right? Dedicated CPU, GPU, a cluster of CPU and GPU waiting for your inference request to come. Again, SageMaker provides you this built-in endpoint offering that with a few lines of code, you can deploy it to the dedicated endpoint. So this endpoint, for example, for tenant 2, the other one is for tenant 1. You can have this, this separated. Another option is that you can have serverless. It means that you really don't care about the underlying servers. You ask SageMaker, and then SageMaker just charge you based on API call. So it handles everything for you. But the last part, and the most important one when we talk about multi-tenancy, how you handle a scale, right? When you have thousands of models, you really cannot afford to have thousands of endpoints. Those dedicated endpoints, they charge you per, they are running all the time, right? They are waiting for requests to come. If you have 100,000 of model, you cannot pay for 100,000 of model, right? So just endpoint. SageMaker has a built-in multi-model endpoint where you define an instance or a cluster of instances in charge of serving lots of models. How it works? Simply, you point your MME instance, that stands for multi-model endpoint, to an Amazon S3 bucket, and you make sure that your model artifact are inside that S3 bucket. In our case, like for every city that we have a model trained, we put them inside that S3 bucket. And then our MME instance, it has this smartness to know that when load and when unload the model. If a request comes and it doesn't have that model, it goes, pick up the model, load the model, and serve the request. When it is running out of memory, first we can implement some auto scaling, of course. But even if it is running out of memory, then it goes unload some of the model and bring a new model. And this is, I talked about Zendesk at the beginning. This is a strategy that they are using, and it helped them to serve lots of customers. Each customer has thousands of models, and it is very, very cost friendly.
So is there any guidance on when to use this way with the multi-model endpoint? Because you talked about thousands of models, but maybe that's not the case for all SaaS builders.
Exactly. And that's why SageMaker provides you different options of like a dedicated real-time endpoint when you have, your model is busy most of the time, right? You want to have dedicated, you care about the latency, right? There might be some latency issue with MME because if your model is not loaded, it takes time, right? It needs to go and bring a model. And if your model is big, it could take, there is a cold start problem. and that serverless, right? So there are options here, but we really need to look at the use cases. But to be honest, if you when you get to that number of tens and hundred thousands of models, assigning dedicated endpoint would be super costly and not realistic. So that's where we usually see customers, they are looking at M&E.
All right. Okay, so we've seen several different ways how to use Amazon SageMaker for multi-tenancy. Did you have something else there, Meran?
And let me just summarize this. Go
ahead.
Your brain fresh, right? So when we go to the Kubernetes, you can compare. So I talk about these built-in features of SageMaker. It provides you a managed workflow execution to put your steps there. Then you can customize this, for each of your tenants by passing different parameters. So, isolated execution of workflow for each of your tenants. Then we talk about model registry, right? So you can have model registry, model group per tenant to store different models, different versions of models for your tenant. And then a very interesting feature is the managed training and processing jobs. SageMaker pipeline, it starts its instance for training, processing purposes when a request comes, and it kills that one when that processing is done. So it helps with the no noisy concern, neighbor concern, and also that it helps you for a cost perspective. You really can calculate the cost for your tenant, and you add up something based on the value of your service does, but it really helps you with that aspect as well.
All right. So this is building SaaS on AWS with Gunnar. We just heard Meran give us how Amazon SageMaker can be used in a multi-tenancy setup for SaaS. And now, well, I guess it's time for Ujwal to give us, show us how Kubernetes and Kubeflow can be used then.
Sure. Let me share my screen here. Thanks, Meran, for walking us through that and setting the stage here. So what I'll try to quickly do here is try to compare with what Meran has mentioned, and then just move towards the demo here. So in the Kubeflow world, you have a constructor profiles. Using that profiles, you can create a namespace for each tenant. So you get a space for each of your tenant, which you use to run your workloads and do all the good stuff. That is different from a SageMaker. In SageMaker world, you don't have this kind of a construct. But once you deploy and once you create a namespace for each tenant, then you would get this Kubeflow dashboard. This Kubeflow dashboard is similar to the SageMaker Studio, which Mehran has showed, where you can create pipelines, run the pipelines, run the experiments, and do all that good stuff, which we will see in a bit here. And then when you are building the pipelines and running these pipelines, what it happens from a cluster perspective is you see the pods coming up, doing the job, and then going away. This is different from SageMaker. SageMaker was dealing with the instances, but here you will see the things are running in the pod and then doing its job and going away. So let me move towards the demo here. So what I did is, like as I mentioned earlier, I used the Kubeflow on AWS open source distribution and deployed that on EKS cluster, and then integrated with the Cognito user pool and also integrated with S3 bucket to store the data or access the data. There is a documentation link. We can provide you that link here, which will walk you through the steps of how to configure all this stuff. Once I did that, and once I log into this portal, what I get is this Kubeflow dashboard. This dashboard, as I mentioned earlier, it has a similar stuff, look and feel of what SageMaker Studio has. You can create notebooks, create the pipelines, and these pipelines are just similar to what Meran showed. You can build these beautiful pipelines here. And for building this pipeline, Kubeflow also provides you a Python SDK. Using that Python SDK, you can easily stitch together, create these components and stitch together. So before I go further, I just wanted to I briefly mentioned that there is profiles, and using the profiles, you create namespace. So profile is a custom resource definition. Basically, if I go through that, let's take an example profile example here. So what you do is you create a custom resource definition of type profile. With that, you specify the profile name. So with this profile name, it creates a namespace for you. So basically what I'm saying is you can use the tenant namespace here and just create that tenant namespace. And within that custom resource definition, you can specify a user. This user, assume this user as a tenant admin, and you would create this user in the Cognito user pool also, so that when you log into this dashboard, the authentication can be done with that Cognito user pool. And the other thing I want to point out here is you define a service account and you map that service account to an IAM role. This IAM role restricts the access to that particular tenant resources. So it's basically this IAM role guides what resources this particular tenant can access. So I created this profile and then created that profile on the EKS cluster, and then it gives me this Kubeflow dashboard. So you can see that the namespace which I've created is tenant4 namespace. And again, it also gives you a flexibility to add additional users to this namespace. So additional users in this case, in a typical use case where you have tenant admin and there are a bunch of other different types of users to it. And then to control the access to those different users, you need to have to create another custom resource definition called authorization policy. Through that, you would authorize or give access only to the features which they would require. So basically, when you deploy the Kubeflow comes with an Istio service mesh. So basically, you will use the authorization policy of that service mesh to restrict the access and define your type of roles, and then map that roles to different users. So now what I'll try to do is I'll try to showcase you quickly on how you can implement the isolation, tenant isolation when a particular pipeline is trying to access the data. So for that, I've written a small, I've used some small code here. Before I show that, launch this Jupyter notebook and show that code, I want to show a few more things. So when I created, as I mentioned earlier, when I created this profile, I attached the IAM role. Let's look at that IAM role quickly here. So if I go to my AWS account, I just created this IAM role. It doesn't have much, if I've attached a simple policy here. And if you look at this policy, what it is doing is it is giving all S3 actions. It is, the resource is basically the bucket name and tenant4/. So basically what I'm saying is only I'm giving access to this particular namespace to access the data or push the data into this tenant4 prefix under this S3 bucket. And then I have just S3 bucket which has tenant4 prefix, and it has, let's say it has these files. Now let's jump on to the Jupyter notebook. So this is Jupyter notebook I used, and I've already pre-launched that, and it has some simple code here. I'll just quickly walk you through that code here. So this is the Python SDK which I mentioned, which you can use to build the pipelines. What this code is doing is simple thing. It's creating one component and then running this component. And when you run this component, it's basically running this method. In this method, what it is doing is creating an S3 client and then putting an object into that S3 client. When it's putting the object, it is going to this particular bucket and then to the tenant prefix in the file 4. As you just saw that we didn't have the file 8 there. Let me run through this code and then see that what happens. So, if I go to the run details, it is still running. And then what I expect is basically this is a happy path, because it underneath service account or the IAM role has access to write the data. It should be able to successfully write the data. So it has completed, the pipeline has completed. If I go to the S3 bucket here, if I refresh this, I see the file 8. So this is basically in a happy path, but let's try to go and write something into other tenants resource. So let's say I'm changing this to tenant 3, just and let's run through this pipeline here. And again, if I go to the run details, if I look at the logs, it is taking a few minutes to run here. So if I look at the logs, what I expect is to see an authorization error, because you have seen, you can see that it gives me an access denied error, which is not allowing me to write to that other part of the S3 bucket. And even if you look at the S3 bucket, you don't see anything prefixed with the name as tenant 3 or anything like that. So that's way that's how you can build the isolation using these pipelines. And there is a documentation which talks you through how you can how you can make your pipeline to talk to your S3 bucket. There is a little bit of configuration you need to do, but the documentation has that information there. Then once you build your pipelines and train your model, the next thing, obvious thing is you need to host that and then create the inference. for creating the inference in the Kubeflow world, you need to use another project called Kser. Kser provides you a model inference platform. You can install that in a serverless mode or in a raw deployment mode. If you use a serverless mode, similar to what Mehran mentioned in the SageMaker world, it takes care of, depending upon the inference request, it takes care of scaling up the resources and scaling down the resources, but it is scaling the resources within the realm of your cluster. And if you do the raw deployment, then you have to handle the management of the resources and all that good stuff. So to do the inference, again, you need to define a custom resource definition called inference service. That's a simple example here. Again, if you go through this definition here, it has the namespace. Basically, you're tying that namespace to your tenant namespace, and then you tie up the service account, which restricts. So you can tie up the service account, and to that service account, you can map the IAM role, which would restrict the access to those resources of that particular tenant. And then you specify Docker image, and then where the S3 bucket, and the S3 bucket where your model is. You can, once you run this inference service on your cluster, then it creates the inference within your namespace of that particular tenant. You can host that as a single model endpoint. And again, if you are trying to look for an option similar to multi-model endpoint, what Mehran has mentioned in the SageMaker world, in the Kubeflow world, there is a new feature called model mesh, which is similar to multi-model endpoint. This is an alpha feature. Still things are developing in this area. It does a similar stuff what the multi-model endpoint does in the SageMaker world, where it loads the models from, depending upon the request, it loads the models from a S3 bucket or from your storage into that, and then manages the resources effectively. The one thing I could not find as of now is that how do you build the authorization around that model mesh? But if you look at the documentation of it, there is or the architecture diagram of the model mesh, there is a routing layer there. So the point I'm trying to make here is that it looks like all the moving parts are already in there. It's just that the documentation has to be published so that we know how to authorize or build some authorization layer around that. So yeah, these are some of the multi-tenancy features which you can leverage if you're building your workloads, ML workloads in Kubeflow.
So Mehran had a great summary of the SageMaker features. Can you do a quick summary, Ujjwal?
Yeah. So yeah, I kind of started off with a little bit of some. So the summary is basically, you create these namespaces where you get this namespace, and within that space for each tenant, within that namespace, you can run your workloads or basically run your pipelines and everything, which underneath the cluster. So basically, the pods are spinning up and spinning down. We are dealing everything with the pods. It looks just similar to what if you're looking from a cluster perspective, it just looks like you're running some piece of software on your cluster, Kubernetes or EKS cluster, and then for as I said, you can manage the different types of users by adding them to these users, and again you get this dashboard specific for your tenant, where you can build your pipelines and everything. So yeah, that's a quick summary of the things. Yeah.
All right. So we have now seen both Mehran and Ujjwal talk about some of the multi-tenancy features within Amazon SageMaker and with Kubeflow. So now we want to hear from the chat, of course. Would you go with Amazon SageMaker or with Kubeflow based on what you've seen so far? So put a comment in the chat. All right. So we've now talked about some of these. Let's see. We also have a question in the chat. Let's bring that up. Is this or can this be integrated with GitHub and CI/CD and so on?
I'm assuming that for the Kubeflow, yes, it should be it's just like any other workload running on Kubernetes or in your Kubernetes or EKS cluster. You should be able to integrate that with the Kubeflow. Yeah, GitHub.
Right. Question from Robin with the fighting words early on there, but now he's asking if Kubeflow can work on Fargate.
Yeah, as of now, as of today, I believe, or yesterday, which I did the research, the Kubeflow doesn't work on Fargate, but there is an issue open on that. We can you can follow that issue under the Kubeflow Fargate version in the EKS world. You can look at that issue. They're still working on that stuff, but again, I would say that a lot of new things are releasing in a rapid phase in this area. things are changing very rapidly. So just watch out for that. But as of today and now, the Fargate doesn't work with the Fargate.
I have a question, Meran. How can I get one of those cool SageMaker shirts?
Yeah, you can. So there are some AWS summits and workshops, right? So that you can attend, and if it's on SageMaker, and I'm sure that they're happy to pass it to you.
Yes. All right. So now we've talked, well, mainly perhaps about partitioning. Maybe we should talk a bit more about isolation. So how to make sure that every tenant only accesses its own models. Should we start with SageMaker again, Meran?
Sure. Yeah. Exactly. When we talk about partitioning, is more about like physical location that or virtual location that you store your training data model. Isolation is a bit one step further. It's more about enforcement, right? You want to enforce that one tenant cannot access. It's not just physical isolation; it's also enforcement. I showed you a little bit about and talk about IAM. But that's the beauty of SageMaker. It has a built-in integration with IAM. So there is nothing between SageMaker and IAM. So you easily can import and use those rules. I've seen different ways of doing this for dedicated tenant in a silo world. How we do it is that during tenant onboarding, we really want to have dedicated resources and services, right, for every tenant. That could include IAM role. So during tenant onboarding, we create a dedicated S3 bucket, and we also can create dedicated IAM role, right, with the dedicated policy that enforce that only this pipeline execution can access to this bucket. On the other hand, for pool and shared model, we want to share services, and also we are going to share pools and IAM rules and policies. IAM also support this. You can parameterize. So you define a shared rule for accessing, for example, to the S3 bucket, but you put a parameter there, something like a tenant ID. So when a request comes to your API gateway or something similar, we usually put like a JOT token. Inside that JOT token, a tenant ID can be decoded, like encoded there. So you decode them. It gives you the tenant ID, and you pass that tenant ID to the SageMaker. And then SageMaker, for example, to access to that multi-model endpoint, just tag that request with that tenant ID, and SageMaker magically, enforce that. So it makes sure that only a model that has the correct tag, which is your tenant ID, will be used. No other tenant. This model is called ABAC, attribute-based access control, when you parameterize access control based on some other attributes. The first model I talked more on the role-based access control that we have dedicated role for each tenant. So both can be supported and deployed here easily. So it's really part of the AWS that services can easily integrate with each other. So and both are like first-class citizen, like IAM and SageMaker, and they can really integrate and work together.
Ujjwal, then, can we implement it in a similar way with Kubeflow?
Yeah, I'll try to take a top-down approach and then try to compare that with what Meran mentioned. So if you're talking about isolation, in this, if you what you can have is like you can have a separate EKS or Kubernetes cluster for your tenants, which is a silo model, depending upon your business use case or the customer requirements. The other option is you can have one cluster which is shared across all your tenants, which is a pool model. Within that cluster, as I mentioned, you would create a namespace for each tenant, and then you need to make sure that the traffic between these namespaces, or there should be a restriction so that the traffic does not flow between these two namespaces. You would use a network policy to enforce that, and within that namespace, you would have a service account that maps to an IAM role. That IAM role would restrict the access to those resources of that particular, or restrict or give only access to that particular resources of those tenants. So basically, as Meran outlined, you were basically using IAM role-based access control here. And the attributes-based access control, it's not available here, or the flexibility not there here. But you mainly or mostly you'll be using the IAM role-based access control as of today for doing that. So those are the ways you would do the isolation piece in here. Yeah.
So it's both about doing whatever you would be running in SaaS with Kubernetes, you have to do that infrastructure isolation. That's one part of it. The other part is actually your implementation of Kubeflow together with IAM, for instance.
Right. Yeah, and the attribute-based control is a feature which, if you have good integration with AWS services, the APIs would help you to do the ABAC or the attribute-based access control there. But if it depends, like if you're running some resources from Kubeflow to the AWS services, and if that AWS service supports it, then you could do some kind of a magic to do that. But it needs a little bit more work and do that. Depending upon the use case, you can peel the onions and do that. It's basically to implement the attribute-based access control. The underneath AWS service should support that APIs if that supports that. And if you are using that AWS service from Kubeflow, then yes, you should be able to do that. Yeah.
And another aspect that we often talk about on this show when we're talking about building SaaS is, of course, scaling and efficient use of resources. So how does, for instance, SageMaker scaling differ from Kubeflow in this case, running it on Kubernetes? Can we do like a comparison of the scalability, perhaps?
Sure. From the SageMaker word, so you can, it doesn't care about, the container or, at least from the user perspective, which is data scientist or ML engineer, you can scale it based on like a number of instances. You need more CPU, more GPU for your training, you can just add it. So you put it under the load balancer, it does everything for you. You only define, I need 5 instances of this type, and it does it for you, right? So it's very, very simple. And it is limitless, like virtually, like, you can, there are some definitely soft and hard limits. So, you can play with it, but you can add as many nodes as you want. Just let me give you an example. Recently, I had a customer that they were looking at very high volume distributed training when they had to train lots of log, like just a streaming log coming to their cybersecurity system. They have some, not Kubeflow, but Kubernetes, MLOps on Kubernetes. And when we were talking together to find a solution, how they can do that distributed training for that high volume of data, the challenge we had was that I had 2 architects in the room, one for the Kubernetes, the other one for AI ML. So they both, the AI ML guy was saying, no, I cannot scale before the Kubernetes can scale. In SageMaker, you really don't need that guy, right? So you just, AI ML guy can scale as much as they want, and they don't care, right? So I think that's the biggest difference, is that in SageMaker, you really can scale based on number of instances and number of nodes that you want. And there are other mechanisms, right? So we talk about serverless. So if you really don't know about your demand, you can go with the serverless or the MME model. So, probably that's the biggest difference, that we don't have that pod layer and worker node layer here. Is about just, you leave it to SageMaker and AWS that, okay, give me those number of instances, and it provided.
And for Kubeflow, Ujjwal?
Yeah, so for the Kubeflow, as I mentioned, when you're using the Kubeflow, when you build the pipelines and launch the notebooks or doing the jobs, doing some work there, if you look at from a cluster perspective, what you will see is that pods coming up, doing the job, and going away. So it looks like as if like you're running some piece of software, any other software on the on the cluster, so where the pods are coming up and going down. So the scaling perspective, what I will say is like you could use the same kind of tools or mechanisms you've been using to scale your clusters and provide more resources to your clusters. You can use some third-party tools like Carpenter or something like that to help you to scale your cluster resources. But as Mehran briefly mentioned, this is where it deviates from SageMaker. Is like SageMaker is more managed service; it will handle those things for you. But here, you have to do a little bit of a heavy lifting of managing your cluster depending upon your workload and everything. But yes, and also as I mentioned, like for the inference, you need to use a K-serve and a K-serve project which can be installed using serverless model, which can scale the resources and scale down the resources. But again, it's doing within the realm of your cluster and using the cluster resources. So you still need to manage your cluster resources. So you could, the good thing is like you could still use the same tools and which you've been using to scale your resources. So these are some of the scalability aspects in the Kubeflow or the Kubernetes world. Yeah.
Okay, so if you just joined us, you're out of luck because we are approaching top of the hour, but we've been talking about AI, ML, multi-tenancy, comparing Amazon SageMaker to Kubernetes and Kubeflow, but the episode will, of course, be available on demand, so you can watch it from the beginning later on. But then perhaps another aspect of it then, and always with SaaS, is cost. So when you want to choose between different technology choices, you often look at cost as well. So can we do a quick cost comparison between the two? Ujjwal, let's continue with you then.
Sure. Yeah. So as I said earlier, if you're looking from a cluster perspective, you're just seeing the pods coming up and going down. So all the cost perspective is like you are basically running that particular your clusters and maintaining the clusters is what it entails to you. Like how much cost you're incurring to run or maintain these clusters. And again, as I said, you can still use the similar tools you've been using to understand the cost bits of or insights of your clusters. Like for example, you can use third-party tool like KubeCost, which can aggregate the cost aspects from a different perspective, like node or namespaces. KubeCost can do that with or it can aggregate the cost by namespaces. Since we tied up the namespace to a tenant, then you can easily get cost per tenant. It's a valuable information when you're doing the multi-tenant workloads. From a cost perspective, to summarize, it's basically how much it is cost is incurring to maintain and run these clusters.
So for SageMaker, mainly you are paying for those underlying instances that they are running your workload for training, pre-processing, and when you host it. So that's mainly the cost. I want to just one more thing here is that when we talk about cloud and cost comparison, it's usually about total cost of ownership, right? It's not just about the platform cost. And one difference here I've seen with the customer is that when we are dealing with like a SageMaker, you only need like more like an AI ML guy and resources and expertise. But with something else that not managed like Kubernetes or running on EC2, you really have another team, right, involved. So you have to pay for your Kubernetes expertise. They are part of the team, right? Is happy to work together, but usually it impacts the cost because it means more resources required. It's not just about platform. You also need to think about those expertise that need to be added to the team.
And well, then hearing about these two options, comparing them side to side, is there also an option of doing something with both, like a mixed type model?
Yeah, I can go first, and that's basically the reality, right? So every customer, they are doing it by their own way, but you always have some legacy from the other team, some requirements, some use cases, some preferences, and the reality is that you really cannot dictate one way of doing this, and might be that's not good. Like always good to have different angle of performing these things. From the SageMaker perspective, if you are mainly on SageMaker and you want to deploy, for example, you train your model, you want to deploy your model on the Kubeflow, you can do it easily. So you can define like a custom step inside your pipeline I showed you. And then, Ujjwal showed you the Python CDK, you can import it and then you can deploy it to those nodes. So there are many customers that, they are using both of these together. If they are mainly on SageMaker, they can deploy it or just train a model, move the model artifact to that platform and use it there.
Yeah, for the Kubeflow world also, yes, there are some SageMaker components built by AWS. We can provide you the links, which basically you can plug them into the into the Kubeflow pipelines, so that you can hand off that work to the SageMaker world. And let me quickly share the screen here and then show that a particular example. So this is one pipeline which comes with the default installation. If you look at this pipeline, what it is doing is using the SageMaker component and then shifting the training job over to the SageMaker world here. So what I'll try to do is I'll try to quickly launch this this particular run. So I've already pre-populated a few things. I just need to populate a few things. So that's the reason I've already pre-populated here. Basically the role name and then the bucket which it is to drop. Let me start running this. Okay, it failed. Okay, that's all right. Let me do quickly here. I can do that again. No worries. Create a run. Choose an experiment. I've already run a couple times, so I do have the things which I want to show, but I want to show it in real time. So no worries. I'll just try this quickly, and then we'll take it from there. It doesn't work. Yes. So it started running now. So if I now let's jump onto the SageMaker, and you should see that it starts off a training job. Under the SageMaker, this is a SageMaker console. I went to the training here, and try to look at the training jobs. If I refresh it here, should quickly start it. And a bit here, let's see. Yeah, it kind of like completed already. Okay, which is good. What happened? There is always something. Yeah, but yeah, let's so when you launch this training job, looks like that I'm not able to find that for some reason.
Yeah.
But yeah, but when you launch this table, I've just run this a couple of days back. When you run this training job, you can see that it has ran on the SageMaker side, and then I specified the S3 bucket where I wanted to drop my model, and it dropped that model to that S3 bucket. I passed it as an input parameter. So you can see that when I run the pipeline here on this side here, it basically hand it over the job to the SageMaker world, and then does the stuff there. So yeah.
So the answer to my question was basically yes on
Yes.
both ends, and that is perhaps also how it might typically look. As Meran said, that it looks different from different use cases and different customers, the way they want to work around it. All right, so that brings us to the end of the show. We have a couple of minutes left for any parting words from both of you before we make a decision, I guess, what to use when we're building. Meran, quick summary, a few sentences.
Yeah, and first, thank you very much for the time. What we have seen, and I've personally seen with the customer, if they have a dedicated Kubernetes team that they are handling all different type of workload on the Kubernetes, they have very good governance in place. They have very good monitoring in place. They usually go with the solution for ML solution based on Kubernetes, and that's totally fine, right? They don't want to treat AI ML differently from other type of workload. For those type of customer, they can look at it case by case. For example, my example of my customer looking for distributed training, they can keep everything, whatever they do today, on Kubernetes, and they can leverage some of those SageMaker offering API for like distributed training, using what Ujjwal showed you. For the type of customer that they really don't want to care about the Kubernetes, they really don't want to have another team, or they want to have really focus on the AI ML part. Their data scientists want to get their hands quickly on the tool. SageMaker probably easier and a better option for them. So both can work together. They can switch easily, but it's more about your use case and your requirement.
I'm just going to bring this up. As always, it depends. Okay, so with that, Meran, Ujjwal, thank you both for joining the show again. Thanks for everyone watching. This has been another episode of Building SaaS on AWS. And we have now done the AI/ML multi-tenancy shootout between Amazon SageMaker and Kubernetes. We've shared a bunch of links in the chat, so go check out the documentation, check out the different services, and well, from this point on, you can simply go build your AI/ML solution for multi-tenancy on SaaS. Thank you all. Thank you very much, and see you again in 2 weeks. Bye-bye.
Thank you. Bye.